Hey everyone, welcome to today's Explainer. I'm absolutely thrilled you're here. Think of me as your senior software mentor for this session, because today we're tackling one of the absolute foundational pillars of Python programming, inheritance. Whether you're completely new to this concept or just looking to solidify your foundation, we're going to break down these concepts and practical applications so clearly that you'll be writing cleaner, way more efficient scripts by the time we wrap up. Let's get into it. Okay. Let's start by addressing a feeling I know literally every single developer has experienced. Are you just totally tired of copying and pasting the exact same blocks of code across your projects? You know how it goes. You write a brilliant function for one part of your app, and then you realize you need almost the exact same thing somewhere else. So you copy, you paste, maybe you tweak one little line, and before you know it, your script is this messy, repetitive nightmare where fixing one single bug somehow creates three more. Well, what if I told you there's a built-in superpower in Python designed entirely to stop that from happening? So here's our roadmap for the session. First up, we'll look at the core of inheritance. Second, we'll explore some real-life parent and child examples. Third, we'll code a practical scenario together. And finally, fourth, I'll share some pro tips for cleaner structures. All right, let's kick things off with part one, the core of inheritance. At its core, inheritance is simply a mechanism where a new class takes on the properties and behaviors of an existing class. Honestly, that's really it. It's literally just the act of passing down traits from one thing to another so that you never have to do the exact same hard work twice. You build a strong foundation once, and then you just let your new classes inherit all that great work. Simple, right? Moving right along to part two, real-life parent and child. To really get this, think about how it works in real life. A child inherently gets certain traits like eye color or height from a parent. They don't have to invent brown eyes from scratch, it's simply passed down to them. Well, Python handles this the exact same way. A child class naturally inherits attributes and methods from a parent class. It's a very direct, relatable line. The logic you already understand from human genetics applies perfectly to how we structure our code. Let's think about everyday objects for a second. Take a generic vehicle. That's our parent. A vehicle has certain baseline behaviors, It moves, it has wheels, it transports things. Now think about a car. A car is our child class. It naturally inherits the ability to drive from that generic vehicle parent. But the child class also adds its own specializations, right? It might add a stereo, or air conditioning, or a specific type of steering wheel. The key here is that the child class builds upon the solid foundation of the parent, rather than starting from absolute zero. Okay, let's get our hands dirty. Part 3, coding a practical scenario. Let's actually look at the syntax. We defined our parent class quite simply with class vehicle, and we give it a driving method. Now, to tell Python that a car should inherit from this, we write class car, but here's the magic. We put the parent's name in parentheses right after it. See that vehicle? Now, notice how we just use the word pass inside the car class? That simply tells Python, hey, we have no new code to add here yet, because the car already absorbed absolutely everything the vehicle knows how to do. And wow, here is the ultimate payoff for setting it up that way. Later in your script, you create a new car object called myCar. You can immediately type mycar.drive and execute it. Think about that. You didn't even have to write the drive method inside the car class at all. It just works instantly. The child class automatically has access to the parent's behaviors. We just completely solved that beginner pain point we talked about earlier. There is absolutely no copying and pasting required here. So what's actually happening under the hood when you type mycar.drive? Here's the exact execution flow Python uses to find the right code. Step 1. Python looks at the child class, the car, and asks, is there a drive method defined right here? Step 2. If it's not found there, Python doesn't just panic and throw an error. Instead, it automatically steps up the ladder to the parent class, the vehicle, and finds the method there. It's basically a highly efficient, logical search party that happens in a matter of milliseconds. Now, as you practice this and really advance in your coding journey, I want you to know that you'll eventually encounter a few different structural configurations. What we just looked at is called single inheritance. That's one child, one parent. But Python is super powerful. It also supports multiple inheritance, where a child can actually inherit from two entirely different parents. And there's multi-level inheritance too, which is kind of like a grandparent, parent, and child sequence. We aren't going to code those out today, but definitely keep them on your radar as you scale up your applications. Finally, let's wrap up with part 4, tips for cleaner structures. All right, here are your golden rules straight from a senior dev perspective. First, keep your hierarchies shallow. Look, just because you can have a great-great-great-grandparent class doesn't mean you should. Trust me, it makes debugging an absolute nightmare. Second, favor simple parent-child links whenever possible. Third, live by the dry principle. Don't repeat yourself. If you're typing the exact same logic twice, it probably belongs in a parent class. And lastly, always optimize to keep your code maintainable. Remember, you aren't just writing code for the computer, you're writing it for the human who has to read it 6 months from now. And let's be real, that human is usually you at 2 a.m., wondering what on earth you were thinking. I think this quote really summarizes the core philosophy of our session perfectly. Good code is like a good family tree, clear, organized, and easy to trace. When you use inheritance correctly, literally anyone looking at your project can easily see exactly where traits come from and how the whole ecosystem is related. Well, we've covered a ton of ground today, from the basic definition to real-world analogies, clean syntax, and even some professional structural tips. You now have the knowledge to completely stop repeating yourself in your scripts. So I want to leave you with this final exciting question to ponder as you open up your code editor. What will your classes inherit today? Thanks so much for learning with me on this explainer, and hey, happy coding!